Hey guys, welcome to my lecture on interconnection of LTI systems. We always want to connect several machines or components to each other to make something more advanced. In signal processing, it's the same story. We want to interconnect the small systems to make something better. There are two common interconnections, parallel and series. In parallel, as the name shows, we have two or more systems connected to each other with a parallel structure. In series, we have two or more systems chained back to back. Now we are interested to find the impulse response for the whole system. Basically, we want to replace this block or this block with just one system that mimics the same behavior. In general, if you want to find the impulse response for several blocks, always start from the output and try to find the relation between output and input. For example, in the parallel structure, we can express yt as a summation of top and bottom branches. Let's call the top one y1t and the bottom one y2t. Naming is absolutely optional, and you can choose the names that you want. Yt is equal to y1t plus y2t. Now look at y1t. Y1t is the output from the top system. As we know from the previous tutorials, for LTI systems, output is basically input convolved with the impulse response. The input for the top and bottom branches is the same, i.e. xt. So y1t is the input convolved by h1t. The same story for y2t. y2t is xt convolved by h2t. xt convolve is a common factor between first and second terms. So let's factor it out. Yt is equal to xt convolved by h1t plus h2t. This is the input and this is the output. As we know for LTI systems, output is input convolved by the impulse response. So look at this carefully. xt convolved by something generates yt. This means this guy is the impulse response of the whole system. So for a parallel structure, the impulse response for the whole system is the summation of all individual impulse responses. Now let's look at the series structure. Again, our mission is to find the impulse response for the whole system. To do so, always start from the output and try to find the relation between the output and input. Here, yt is basically the input to the second system. Let's call it vt, convolved by h2t. Again, yt is vt convolved by h2t. Now look at vt. Vt is simply the output from the first LTI system. So let's replace vt by xt convolved by h1t. Let me write the rest. Now this is the input and this is the output. As we know for the LTI systems, output is input convolved by the impulse response. So look at this. xt convolved by something generates yt. This means this guy is the impulse response of the whole system. So for a series structure, the impulse response for the whole system is the convolution of all individual impulse responses. Let's go for a bigger system by combining parallel and series structure. This system is given where all the systems are LTI and the goal is to find the impulse response for the whole system. Again, start from the output. Let's call this signal Vt. Yt is Vt convolved by h3t. What is Vt? Vt is basically the summation of three branches. From the top branch we get pure input, xt. From the second one we get xt convolved by h1t. And from the bottom one we get xt convolved by h2t. Now look at this summation. There is a convolution sign here and here, but the convolution is missing from the first term. So we cannot factor out xt convolved. To do so, we need to use a very simple trick. As I explained in the convolution examples tutorial, by convolving xt with a shifted delta function, we get the shifted version of xt. From this property, it's obvious that when we convolve xt with a delta function which is not shifted, i.e. t0 is 0, we get the same xt back. This means you can write xt as xt convolved by delta t. Let me write the rest. Now we have a common factor, xt convolved, so let's factor it out. Here we go. By replacing vt here, we get this, convolved by h3t. This is the input and this is the output. For an LTI system, input convolved by the impulse response is equal to the output. Therefore, we can conclude that this big guy is the impulse response of the whole system. Let's solve one more example. This structure is given with the LTI systems, and the question is, what is the impulse response for the whole system? Again, the same story. Start from the output. Let's call this signal Vt. Yt is the summation of two branches. From the top one, we get xt plus Vt from the bottom branch. Now, what is Vt? Let's call this guy Zt. Vt is basically Zt convolved by h2t. Now, what is Zt? Zt is the summation of two branches. Both branches have the same input, i.e. xt. So Zt is xt convolved by h1t plus xt from the bottom branch. Let's replace Zt here. Vt becomes this, convolved by h2t. Let's apply convolution to the parentheses. We need to apply convolution to both terms inside the parentheses. Now I'm going to replace Vt here. Yt becomes this. Again, there is xt convolution sign here and here, but the convolution sign is missing here. Similar to the previous example, you can write xt as xt convolved by delta t. Now you can factor out xt convolution sign and yt becomes this. This is the input and this is the output. Again, for an LTI system, input convolved by the impulse response is equal to the output. So we can conclude this big guy is the impulse response of the whole system. Okay, that's it for this tutorial. If you have any question or feedback, please write it in the YouTube comments section. Thanks a lot for watching this video, don't forget to subscribe and see you guys in the next tutorial.